So yesterday we spoke about interface. So I am creating an interface called Mystack interface. So what is an interface? What is an interface? Interface is a blueprint of class. Yesterday, most of you who have submitted the assignment has written it in very short form. Actually, you have to elaborate. It's a blueprint of class. Interface specifies what a class has to do, but not how to do. It contains a set of abstract methods without implementation, without any implement. So the difference between class and interface is that class contains methods as well as implementation. Class contains methods and their implementation, whereas interface contains only method name, method prototype, but not the implementation. So what is the purpose of interface? To achieve, first of all, to achieve abstraction, total abstraction. See, we present an interface, what we do, but we don't present the classes which implement that. Different classes may implement it in a different way. So it is used to achieve total abstraction. And some more points you need to remember is that it can also contain variables. Interface can also contain variables which are final and static, implicitly. What we mean by final? It cannot be changed. Final is a variable which cannot be changed. What is a static? Only one copy of the variable. And one more difference between is that interface cannot be instantiated. What we mean by instantiation? Creating an object. Instantiation means creating an object. You cannot create objects from interface. You can create objects from a class, but you cannot create objects from any. But one more thing is, interface can be inherited. Interface can be inherited. We can create one interface inheriting the other interface, and interfaces or the mechanism by which we can achieve which type of inheritance? Multiple inheritance. Actually, Java doesn't support multiple inheritance, but by using interfaces we can achieve multiple inheritance. Then one class, how we achieve multiple inheritance? One class can implement more than one interface. This is how we achieve multiple inheritance. One class implementing different interfaces, and one interface can be implemented by more than one class. One interface can be implemented by more than one class. These are the fundamental points you have to remember regarding the interfaces. Now, you know about stack, right? What is stack? What is a stack? It's a data structure. Stack is a data structure which, based on the principle first in first out, or stack last in first out. Stack, a pile, right? So these are the points about this one. It has nothing to do with our this program. Let us say, so what is stack? Stack follows the principle LIFO, last in first out. There will be stack one upon the other. The top element is called top of the stack. So what are the operations we implement on stack? Push, pop, those are the basic operations. Is full, is empty, also you can do that, but basically is push and pop. Push will insert an element into the stack. Pop will delete or remove an element from the top. So I call it as Mystack, and this is an interface. In the interface I define only the abstract methods. What we mean by abstract? Hiding implementation. So only abstract methods. So what type of method is push? We need an item or element to be pushed into the stack. So this is a void method. Void push into item. Then what about pop? There is nothing we pass. It will take the first element, top element, and it will pop, it will return that element. So it is integer. Let us say I am using only integers in the stack. I will call it as int stack, let us say, or int stack, integer stack. So this is interface, right? This is interface. Only two abstract methods. Two abstract methods. Now, let us define a class. Let us define a class that implements this stack. That implements this stack. So, let us define a class. Let's name that class as Mystack. Mystack. What happened? I think already that name is there. So I will raise it as one stack. Okay, one stack. So this is public class one stack. Now to get these to implement, to override these methods, what we write here? Implements interface name Mystack annama, instack annama, instack annama. So let us name it as instack, or rather I will keep it as it is, Mystack. Okay, so implements Mystack. Now I have to override those methods. So for overriding those methods, first of all I need an array. So I will define an array, maybe list, and there is an integer top of the stack or top. These two are the variables in an array and top of the stack. So now, and I will write a constructor for one stack, the constructor, and will pass the size. So we will create with size maybe some 5 or 10 elements, the list of 5 elements, and we will initialize. Initially what will be the top? 0? Initially, when there is no element, -1. The moment you insert, that will be initialized to 0 plus 1, then the 0th element will be. So programmers, we will count from, I have seen a meme yesterday, children are playing this hide and seek. General people will count from 1, 2, 3, 4, but a programmer will count from 0, 1, 2, 3, 4. That should be our mind. We should be habituated to programming. Okay. So we will initialize this one, list, and done. Yes. This is the constructor, right? What is this? Constructor. Now, what about push, void, push, int, item. So what shall we do? First of all, we should check whether the stack is full or not. Empty. Empty unna manaki ibbandi ledhu, but full undakunda unte chalu. So what shall we do? If top is equal to list dot length minus 1. If a list is capacity 5, the elements will be from 0 to 4. If the list is 10, the elements will be from 0 to 9. So, if the top is equal to 9 means it is already full. So, if top is equal to list dot length minus 1, that means what I have to print? System dot out dot println. What I have to print? Stack is full. Stack is full. And else. And I will return 0. We will return 0 from here. Else, what shall we do? Tell me. This is a textbook program. Even in textbook we have this stack implementation. Yes. What we have to do? Stack is not full. So first of all we should increment the top. Suppose now the present top is 3. You have to increment the top. Then in the list, the top element will be equal to the item you are pushing in. And if you want, you can print, it's not compulsory. This is not compulsory, just to know. Void push. Next, what about pop? Int pop. What we are doing? We are overriding, right? We are overriding. What is the code? First of all, what we have to check when you are removing the element. Already if it is empty, you cannot remove any element. So we have to check whether it is empty or not. How to check whether it is empty? Top will be equal to -1. If the top is equal to -1, there are no elements. So first of all, I will have to check if top is equal to -1. Then obviously it is system dot out dot println. The stack is empty. Then return 0. Return it void kada. In void we cannot return. Sorry, we have done this as void. So this here we have to return an integer because it is an return type is integer. Return 0. Then else it's not your bell, it's example. Then else top list of int element nth element is equal to list of top. Top is decremented and return element. Return element. Whatever we remove, that will be returned. That is else. So this is the interface implementation for the stack. This is one type of stack. I called it one stack. Now let us write the main function. Public static void main string args. Now I have to create one stack object because this is class one stack. So one stack stack per S annama. Let us call it S is new one stack with capacity 5, let us say, with size as 5. That's what the constructor says, right? In the constructor we pass the number of elements. So now when I use this, a list will be created with size 5 and top will be equal to -1 automatically. So now I have to push the elements, right? I have to push the elements. How many elements I can push? 5 up to 4. 0, 1, 2. And first top will be 0, then 1, then will be, I can push 5 elements. I can push 5 elements. So let me I can use push 10, then I can write it 20, 30, then 40, then push 50. To check whether it's I will also use push 60. Actually 60 cannot be pushed because already stack will be full. Then I will use and I will use pop for 5 times. For that I will use a for loop for int I is equal to 0, I is less than 5 because I given 5, less than 5, I plus plus maybe some integer x equal to pop, or otherwise I will directly print system.out.println the element popped from the stack is pop. Element will be popped because I want a new line. So this will be done for 5 times, right? Or I want to make it 6 times to check the other condition also. So I think this is enough. This is this one. Then I don't need this. Yeah, sorry. S dot push, because it is not a non-static method. If it is a static method, I can write push, but it is not static. Static means all the objects have a single copy. Me class under ke there is only one classroom, so classroom is static. But name, every object has a name, that is not static. So static means all the members of the class has a single copy, that is static. So S dot push. Similarly, what is here? S dot pop. And what is this here? So else he is here, then I have to close the let us make it public. And this also as public, because we are overriding. No red marks. Save. So what is the output of this program? A list of 5 elements will be created. First 10 will be pushed, 20 will be pushed, 30 will be pushed. So whenever we push, there will be a message, the item is pushed. The item may be, if I am very specific, okay, 10 is pushed, 20 is pushed, 30 is pushed, 40 is pushed, 50 is pushed. Then I also written 60, and there will be a message, stack is full. Then pop, so the element popped from the stack first. Which element will be popped? 50, then 40, then 30, then 20, 10, then it will be, because it is 6 times, it will say stack is empty. So let us see whether that output will come or not. So item 10 is pushed, item 20 is pushed, 30 is pushed, 40 is pushed, 50 is pushed, then stack is full. Then element is 50 is popped, 40 is popped, 30 is popped, 20 is popped, 10 is popped, then stack is empty. And there is one more, because there is nothing, we have returned we can say we have returned 0 actually. Okay, this is one implementation of the stack. So we defined an interface here and we implemented it here. This is an example of implementation of interface. Note it down, please.